Hi, my name is Glenn Weinreb, and I am director of a nonprofit that does research on how to solve the climate problem. And we differ from other organizations in that we focus on how to do this at the lowest cost to society.
Or, more specifically, we focus on the following question. If the world were to achieve a complete decarbonization over 30 years at the lowest cost, what specific actions would be taken? And what would be the associated expense?
At lowest cost is important because it reduces the number of potential solutions that are considered. And in many cases, our conclusions are not what you might think.
For example, the math tells us resolving climate change is not blocked by political constraints or economic constraints. The majority of lawmakers want to tackle climate change, and the cost to set up a green economy is reasonable, especially if done at the lowest cost, and especially during the early years. The problem is related more to confusion over the cost and impact of each so-called climate remedy. One might refer to this as the fog of climate. Many programs are expensive and do little, whereas others are cost-effective yet undersized. This is another way of saying that climate is often hijacked. In other words, people use climate to make money. At first glance, this might seem okay. However, the hijackers focus on their own financial interests and not at reducing large amounts of carbon dioxide at the lowest cost. You might not care if somebody else wastes their own money. However, this has enormous implications. When cost effectiveness decreases, so does political support. And when political support decreases, so does program size. And we need large program size to tackle climate change. We are looking at replacing the world's carbon-based infrastructure with green infrastructure, and this involves a lot of green energy construction, more than what we are accustomed to. Ultimately, lawmakers need better policymaking tools to help them know when they are being hijacked and help them determine how to facilitate large-scale construction at the lowest cost. Okay, so that's the 2-minute version of the climate solution. The next 25 minutes provides more detail. Yet before we begin, I should tell you a little about myself. While in college, 40 years ago, I started a company called GW Instruments. This was covered in Macworld magazine in 1985, as shown here. We design and manufacture hardware and software products that automate factories and research laboratories. So my background is engineering, R&D, manufacturing, and economics. Also, I am the director of a nonprofit that does research on how to tackle climate change. And I have published over 30 articles on this topic, as shown here. And I am the author of a climate book called A Plan to Save the Planet. This is open source, which means anyone can copy and edit the original Microsoft Word file and produce their own plan, all for free. 7,000 paperbacks were distributed during the first half of 2023. Shown here is a palette with 2,000 free climate books. If one wants to read a free PDF file, they are welcome to do so via the link shown here. We recently set up a YouTube channel called The Climate Solution. Focuses on how to deal with the climate problem at the lowest cost and at large scales. This is that channel's first video, and it is a summary of the book. Video 2 explains how much it would cost to fully decarbonize the electrical power grid. Video 3 looks at government's options, and video 4 looks at how to increase R&D responsibly. The purpose of our videos is to explore how to reduce large amounts of carbon dioxide while observing economic, technical, and political principles. In other words, we focus only on what works for real. Okay, let's begin by reviewing the climate problem. Our society currently burns coal, oil, and natural gas to generate electricity, make materials, and push vehicles. The exhaust contains carbon dioxide, a greenhouse gas that warms the planet. Unfortunately, global warming is harmful. For example, heat dries out soil, which leads to less food production and higher food prices. And heat causes large ice masses to melt, which ultimately threatens coastal areas. The size of these problems is enormous, and this raises a fundamental question. Is our society adequately tackling the climate problem? This is difficult to assess since some reports say the problem is terrible, whereas others imply it is being handled. Ultimately, we want to know, in total, how are we doing? To answer that question, we need to aggregate the impact of all efforts and estimate future carbon dioxide emissions based on existing government policies and society's behavior. Doing this responsibly is a tremendous amount of work. More specifically, it requires a team of economists and scientists to study all aspects of the problem. An example of this is a team that was put together by the United Nations. A summary of their findings is shown here. This is one of the most important graphs published in 2023. The red plot is an estimate of carbon dioxide emissions from the world over the next 75 years based on existing national laws and consumer behavior. This shows it increasing over the next 50 years, not decreasing. And this would cause the average global temperature in the year 2100 to be approximately 3 degrees warmer than what it was 100 years ago. Also, it would keep going up and be 5 degrees warmer 100 to 200 years from now. This would be catastrophic. Also shown is a green plot that indicates what the world would need to do to limit warming to 2 degrees with no further warming. To do the green plot, nations would need to enact new laws that require transitioning to a green economy. This is not happening. However, there is evidence that political support for this exists if done at the lowest cost, and we'll explain what we mean by that in a moment. But first, let's look at future carbon dioxide emissions from the United States based on current U.S. government policies and consumer behavior. The U.S. Department of Energy expects annual U.S. carbon dioxide from burning fossil fuels to decrease from 4.8 billion tons this year to 4.0 billion tons 30 years from now. This is only a 20% reduction over 30 years and is far short of our planet's needs. Both of these projections take into consideration the building of solar farms, the decrease in green electricity costs over time, the impact of R&D, entrepreneurial ventures, national climate policies, consumer behavior, etc., and they do not see the world adequately tackling the climate problem. In other words, our so-called climate remedies are small relative to problem size. So what is problem size? The world consumes 580 exajoules of energy each year, and one can calculate how many large wind farms, large dams, or large solar farms one would need to replace this energy if it were converted to electricity. According to the math, this energy corresponds to 17,000 Hoover dams, 22,000 London Array wind farms, or 44,000 Topaz solar farms. Shown here are pictures of these facilities. This might seem like a lot, and it is. Also, it works economically, kind of. If these were built globally over several decades, less money would be spent on fossil fuel production. In other words, workers would do green stuff instead of non-green stuff. And consumers would pay for green stuff instead of non-green stuff. Ultimately, consumers would see the cost difference as an additional cost. To do this, one would need new laws that require consumers to pay that additional cost, and then capitalism would do the rest. The numbers shown here might seem terrible. However, what really matters is the magnitude of that additional cost, and we'll look at that in a moment. Okay, so that's the problem. Now let's explore the solution. We're going to look at this from 3 perspectives: physics, economics, and politics. First, the physics. Quantities of gases are often defined by their weight. For example, a barbecue grill canister might hold 10 kilograms or 22 pounds of natural gas. When working with climate, carbon dioxide gas is typically quantified in units of metric tons. For reference, a metric ton is 1,000 kilograms or 2,200 pounds. This is the weight of a small car. The typical American home emits 4 metric tons of carbon dioxide each year due to electrical power consumption, and the typical American car emits 5 metric tons of carbon dioxide each year due to burning gasoline. The climate solution is to significantly reduce carbon dioxide emissions. This is commonly referred to as decarbonization, and there are roughly 3 areas that need to be addressed. These are electrical power generation, transportation, and the making of materials and chemicals. Materials includes things like metals, plastics, glass, and concrete, and chemicals includes things like liquid ammonia that is used to make fertilizer. Ultimately, we need to replace sources of energy that emit carbon dioxide with sources that don't. In other words, build more solar farms, build more wind farms, build more hydroelectric dams, etc. Okay, so that's the physics. Now let's look at the solution from the perspective of economics. We begin with 3 questions. 1. If we decarbonized over 30 years, what would we physically do each year? 2. How much would this cost? And 3. How would we push people to implement? And to make this easier, we add 2 requirements. Requirement number 1 is the problem must be resolved at the lowest cost to society. And requirement 2 is the solution must be accepted by a majority of lawmakers. These 2 requirements might seem obvious. However, they are rarely implemented for a variety of reasons, which we will discuss in a moment. Requirements are helpful since they reduce the number of possible solutions that are considered. In other words, they help us focus. At the heart of the climate problem is a parameter that is rarely talked about. It is called decarbonization cost, and it refers to the number of dollars needed to reduce emissions by 1 metric ton of carbon dioxide. For each project that reduces carbon dioxide, there is a project cost and an amount of carbon dioxide that is reduced. One divides these 2 numbers to calculate decarbonization cost. For example, if you spend $300 to reduce carbon dioxide by 6 tons, then decarbonization cost works out to $50 per ton of carbon dioxide. There are many ways to reduce carbon dioxide. Some have low decarbonization costs, whereas others have high. Less than $50 per ton is considered low, whereas more than 50 is considered high. Building solar farms, building land-based wind farms, building hydroelectric dams, and building nuclear power plants in China often have low decarbonization costs, while most other so-called climate remedies often have high decarbonization costs. Okay, so let's look at how decarbonization might work in the United States. The U.S. emits approximately 5 billion tons of carbon dioxide each year due to burning fossil fuels. And in theory, this could be reduced 1/30th each year over 30 years to hit 0 in the year 2053. 1/30th of 5 billion works out to 170 million tons a year. Therefore, emissions would need to decrease 170 million tons each year over 30 years to get to 0 30 years from now. This is plotted here with time on the horizontal axis and carbon dioxide emissions on the vertical axis. We refer to this as the green line, and this is a theoretical goal for how the United States might tackle climate change. Okay, so how much does this green line cost? If we decarbonized at $24 per ton, for example, then the cost for 1 year would be $4 billion. And the cost per person would be $12, since 4 billion divided by the U.S. population of 330 million is 12. These costs would appear as an increase in the cost of goods and services. $24 per ton is a typical decarbonization cost when building solar farms and wind farms. However, if one decarbonized at $48 per ton, for example, instead of $24, the cost shown here would be twice as high. Okay, so that's 1 year. Now let's look at what would happen over 10 years. Carbon dioxide emissions would continue to decrease, and additional costs would continue to increase as shown in this table. Also, evidence of climate change is likely to increase too, and this would cause the public's tolerance of costs to also increase. In other words, to survive climate change, we need costs to stay below tolerance of costs as we go through time. For example, we need the public to accept $12 in year 1 when they are moderately nervous about climate, and accept $120 in year 10 when they are more nervous. We talked about how some climate remedies have a low decarbonization cost while others have high. This begs the question, why might a society engage in high decarbonization cost activity? There are several reasons, one of which is the selling of climate. This is when companies, universities, and governments talk about the things they do to reduce carbon dioxide. They do this to improve their standing with the public or to sell a product or service. However, their efforts are rarely quantified. More specifically, cost, number of tons of carbon dioxide reduced, and cost per ton are rarely specified. Unfortunately, the selling of climate sometimes causes the public to feel like the problem is being handled when it is not. Another reason why we might engage in high decarbonization cost activity is the delegation of decarbonization. This is when our society encourages individuals, companies, cities, and states to reduce carbon dioxide. At first glance, this might seem reasonable. However, this strategy is flawed since these entities rarely have the physical ability to do this with a low decarbonization cost. This is like asking a city mayor to build a car from scratch in the local shop. Can he do it? Yes. However, it might cost him 100 times more than what the auto industry can do with factory mass production. Okay, so many so-called climate remedies are not cost effective. This begs the question, how do we tackle climate change at the lowest cost? The answer is the power company. This is because they can use markets to drive down costs. For example, they can have builders of solar farms and wind farms compete with each other to reduce costs. Also, large facilities have low overhead costs per unit electricity. Imagine trying to place 20 solar panels onto 1 million different homes. One would incur project overhead costs 1 million times. For example, for each house, one needs customer acquisition, mechanical design, electrical design, permitting, mechanical installation, electrical installation, inspection, etc. Alternatively, if one installs 20 million panels at one large solar farm, they would not see overhead every 20 panels. This is why residential solar cost per unit electricity is approximately 3 times more than solar farms. Notice we do not encourage homeowners to install portable power generators in their basements. Instead, we let power companies generate electricity since they can do it for less money. We should do the same with climate change. In other words, we should let the power company handle it. Power companies have monopoly power and are therefore set up as utility companies. This means they are overseen by government, and government mandates that they provide electricity at the lowest cost independent of CO2. In other words, power companies are supposed to ignore the climate problem unless told otherwise by government. Also, this means that government makes major electricity policy decisions, not power company executives. In a sense, the climate solution is a phone call from government to CEOs of power companies, requiring them to decarbonize the grid at a specific rate and pass additional costs on to consumers. The phone call is a metaphor. In practice, the climate solution is a new law that requires power companies to decarbonize the grid. But at what rate? President Biden wants the U.S. grid to be 100% green by the year 2035. This is another way of saying he wants power companies to get him approximately the first third of the green line at the lowest cost. Currently, this does not have majority support. However, if there's one thing the U.S. government could do that would have enormous impact at relatively low cost, this is it. Currently, approximately 40% of U.S. electricity is green, and this advances approximately 1% per year. China advances at a similar rate. However, Germany is moving 5 times faster, and their grid is expected to be fully green by 2035. In other words, Biden wants to do what Germany is doing, and Germany is demonstrating this is feasible. Germany has moved rapidly over the last 7 years, in part due to a desire to be energy independent. In other words, they do not want providers of natural gas to threaten them with supply disruptions. The United States produces their own natural gas and oil and is therefore less concerned about energy security. In other words, importers of fossil fuel are more inclined to go green. Okay, so that concludes our discussion of climate economics. Now let's look at climate politics. Some regions produce and export carbon-based fuels, whereas others import. One might think of these as fuel exporters and fuel importers. Fuel exporters are economically hurt by decarbonization. However, the opposite is true for importers. They benefit in 2 ways. One, they gain local green jobs when nearby wind farms and solar farms are constructed, and this occurs while carbon jobs are lost elsewhere. And 2, importers save money when decarbonization causes fuel prices to decrease due to less fuel consumption due to decarbonization. As one can see from these maps, fossil fuel is only produced in select areas. More specifically, 2/3 of the U.S. states do not produce coal or natural gas. In other words, most of the U.S. economically benefits from transitioning to a green grid. So that's fossil fuel importers and exporters. Now let's look at how people feel about the climate problem and how they feel about decarbonization costs. This leads us to 3 climate groups. Group 1 is concerned about climate change. However, they are not too concerned about decarbonization costs. Group 2 is concerned about climate too, yet is only willing to go green with low decarbonization cost remedies. This typically entails building more solar farms, more land-based wind farms, etc. However, this does not include solar panels on homes or electric vehicles due to high decarbonization costs. And Group 3 is not concerned about climate. According to survey, 95% of U.S. Democrats are concerned about climate, and almost all Democrats in Congress supported the U.S. Inflation Reduction Act. Much of this is not lowest cost decarbonization. Therefore, this is Group 1. Also, according to survey, 40% of Republicans are concerned about climate, and none of the Republicans in Congress supported the Inflation Reduction Act. It contains too many high decarbonization cost programs. This is Group 2. And the remaining Republicans are not concerned about climate. This is Group 3. Group 1 is not large enough to form a majority in the United States. Therefore, to tackle climate change in the U.S., or real, one would need support from Group 2. In other words, Group 2 are the swing voters. Okay, so what do they want? Part of my research has been to study statements made by Group 2 lawmakers to get a sense of this. They want to decarbonize at the lowest cost. They want detailed reports on what this entails. They want a plan that can be reviewed, audited, and improved. They want more R&D, and they want video that explains to the public a reasonable national climate strategy. My organization has worked on these things and has developed free materials at the link shown here. Group 1 lawmakers have a basket of so-called climate remedies, some of which have high decarbonization costs and some of which have low. Group 2 lawmakers, on the other hand, prefers baskets that only have low decarbonization cost programs, and they are willing to run some of these at large scales. Group 1 likes their basket and is fond of its contents. However, some Group 1 lawmakers might be open to a grand climate bargain where high decarbonization cost programs are reduced in return for increasing the size of low decarbonization cost programs. Ultimately, more carbon dioxide would be reduced at less cost. Lawmakers sometimes agree on basic principles and then have government employees explore implementation. For example, Group 1 and 2 lawmakers might agree to enact a federal law that requires transitioning to a green economy over 30 years at a constant rate at the lowest cost. In other words, do the green line at the lowest cost. After agreeing on this kind of principle, lawmakers would also need to produce a list of things they want to know. In other words, a list of things that are calculated by government economists and placed into a decarbonization report. Shown here is an example list with 7 items. 1. What is physically being done each year? 2. How much does this affect the price of natural gas? 3. How much money is saved due to a lower natural gas price? 4. What is the additional cost of the greener electricity? 5. How many green jobs are gained? 6. How many carbon jobs are lost? And finally, a table that shows for each so-called climate program, the cost, the amount of carbon dioxide reduced, and the cost per ton. In other words, if there were 50 programs, a table with 50 rows and 3 columns would be produced. After receiving a decarbonization report, lawmakers might have it audited for accuracy and might consider different sizes for each program. In other words, it is likely they would produce variations of the proposed plan and want a decarbonization report for each. Calculations made by economists are influenced by policy options. For example, green electricity costs less if a government office has the authority to demand right-of-way for new power wires. That's an example of one policy option. However, there are many. Also, after getting one report, lawmakers would want to know the effect of changes. In other words, they would want to produce variations of the suggested plan. Unfortunately, generating many decarbonization reports manually is too laborious. And this is where we hit the core of the climate problem. One might consider this the climate conundrum. To resolve this, one would need a website that allows the user to specify an energy policy, click Calculate, and then see a decarbonization report several seconds later. This does not exist. However, it could be developed. Also, this is needed for all nations, not just the United States. The hard part is creating models that make these calculations. However, these already exist. An example is the U.S. government NEMS model. In other words, the missing piece to the climate puzzle is a website user interface for existing models. Lawmakers tend to trust government economists. However, they are often skeptical of outsiders. This is because it is too easy to cook up phony numbers, wittingly or unwittingly. Therefore, this website would be most relevant if overseen by government economists who understand decarbonization costs. Such people actually exist. In the United States, they are at the Energy Information Administration, or EIA for short. They have 325 people, and they have a $125 million a year budget. It is possible we are a few computer programmers away from creating the needed tools. In conclusion, we need to work smarter, not harder. And that's it. That's the climate solution. Okay, now let's do a quick review. Little is being done. This is due to the fact that the climate remedies are small relative to problem size. To fix this, we need new laws that require consumers to pay the additional cost of the green products. Capitalism will then do the rest. A majority of lawmakers will not do this unless it is done at the lowest cost to society and it is backed up by detailed decarbonization reports. A report like this could be generated by a website after the user specifies policy. Carbon dioxide emissions from the U.S. are 1/8 of global emissions. Therefore, we need good policy making tools for all nations. And that concludes our presentation. In summary, power companies and government economists are the key to solving the climate problem. However, they will not proceed without the right instructions from lawmakers. And the key to producing these instructions is more clarity on what it means to transition to a green economy at the lowest cost and in a way that is politically feasible. And to get that clarity, we need website-based policymaking tools overseen by government economists. According to the math, climate change does not need to be difficult. And for more climate solution videos, visit the link shown here. Thank you for listening.